Okay, let me take this chapter 6 post test, and we'll take a look at it. This says divide. So we got 15, a to the third, b squared, plus 25, a squared b, over 5, a squared b. 15 a to the third b squared plus 25 a squared b over 5a squared b. Okay, now even though it says divide, the fact that we got a single term down in the denominator means we're going to split these into separate fractions. So I'll put my first term, the 15a to the third b squared over 5a squared b, plus, and I'll put my second term over that. And then we're going to simplify these fractions. 15 and 5 are both divisible by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Now here we have a to a power over a to a power. So we're going to subtract a smaller exponent from a larger one. 3 minus 2 is 1. And we'll have a to the first power where our larger exponent was, which was on top. Now here we got b squared over b. And this is like b to the first. Remember, if you don't have an exponent, you can put a 1 there. So we got b to a power of b to a power. You subtract smaller exponent from larger one. 2 minus 1 is 1. So we're going to have b to the first power where our larger exponent was, which is on top. Plus 25 and 5 both divisible by 5. 25 divided by 5 is 5. 5 divided by 5 is 1. These a squareds cancel and the b's cancel because they're exactly the same. So that gives us 3ab plus 5. 3ab plus 5. Okay, divide and simplify. So we got x squared minus 5x minus 6 over 2x squared minus 72 divided by x squared plus 7x plus 6 over x squared plus 12x plus 36. First off, we never actually ever divide. We're going to immediately rewrite as multiplication. So we got x squared minus 5x minus 6 over 2x squared minus 72 times, and you rewrite the division as multiplication, and you flip the fraction following the division symbol. Flip the reciprocal. Top goes to bottom, bottom goes to top. Now I'm not going to show all the steps for factoring. If you have any questions on the factoring, you can contact me. But this first fraction, the top is PSD. So we've got x squared x, no number for x squared. The bottom here is our GCF, because they're both divisible by 2. And top here is PSD, and the bottom is PSD for the same reason as the first one. So this is going to factor as x minus 6 times x plus 1. Here I'll factor a 2 out, and that gives us x squared minus 36. This one factors as what does it factor as? X plus 6 times x plus 6. And this one factors as x plus 1 times x plus 6. Now it's not completely factored yet. X squared minus 36 is the difference of two squares, two terms of the minus trinket. So this becomes x minus 6 times x plus 1 over 2 times x plus 6, x minus 6, and everything else carries down. Now that we've factored everything, we can see what can cancel. Your only guide is one's on top, one's on the bottom, and they're the same. Here's an x minus 6, here's an x minus 6. Here's an x plus 1, here's an x plus 1. Here's an x plus 6, here's an x plus 6. Here's an x plus 6, and here's an x plus 6. So it looks like we're left with a 2 down below here, and of course you never leave blank for a fraction, so you can put 1 up on top. So 1/2 is our answer. Well, that works out pretty nice. Not very nice to solve the problem, but the answer is nice. Okay, so 1/2. Now this says perform each indicated operation. So let me clear this off. And we got 7x squared minus 13x minus 2 over, is that x and y? Okay, I do have a mix. Plus y minus 2 times y squared plus 5y minus 6 over 35x squared plus 12x plus 1. And I'm going to go ahead and rewrite this as multiplication, because we know we never work with division. And I do that by flipping this second fraction, taking reciprocal of it. So I got 15x squared minus 2x minus 1 over 5x squared minus 8x minus 4. Now let me check everything here. Okay. This is key number because we got x squared, x, no x, and there's a number in front of x squared. This is PSD because we got y squared, y, no number in front of your y squared. This is also PSD, same reasoning, and this is key number. Same reasoning as the first part here. And also key number, and also key number, because they all have numbers in front of the x squareds. And they're not GCF. Okay, so that's going to factor as 7x, x to 1 minus plus 7x plus 1 times x minus 2. This one factors as y plus 2 times y minus 1. This one factors as y plus 6 times y minus 1. This one factors as 7x plus 1 times 5x plus 1. This one factors as, let's see, 1 minus plus. Factors as 5x plus 1 times 3x minus 1. Let me double check that. Yeah, that's right. And this one factors as 5x plus 2 times x minus 2. Let me double check that one. Yeah, that checks. Okay, now we're going to cancel. Only guideline is one's on top, one's on the bottom. And they're the same. 7x plus 1, 7x plus 1. X minus 2, x minus 2. Y minus 1, y minus 1. 5x plus 1, 5x plus 1. I don't think I see anything else in cancel. So it looks like on top we're left with y plus 6, 3x minus 1. On the bottom, looks like we're left with y plus 2 and 5x plus 2. Let me double check everything. These aren't trivial problems. X minus 2, 5x plus 1, 5x plus 1, y minus 1s. Okay, that looks correct. Okay, so put a fraction up here, and we got y plus 6, 3x minus 1, y plus 2, and 5x plus 2. Now this one, we want to solve this equation. Let me clear this off. And then we got 8 over x minus 1 equals 16 over x squared minus 1. Solve the equation, select the best choice, comma separate answers, no solution. Okay. Well, first thing, this is a rational equation. First thing we need to do is factor our denominators. X minus 1 I can't do anything with, but the x squared minus 1 is the difference of two squares. So this becomes 8 over x minus 1 is equal to 16 over x plus 1, x minus 1. Now we need to figure out what our LCM is. So I start with my first factor, the x minus 1. I'm looking for the greatest number of x minus 1s in a single denominator. So 1 here, 1 here. So the greatest number of x minus 1s in a single denominator is 1. Now I go to my next factor, and I'm looking for the greatest number of x plus 1s in a single denominator. There's none here, there's 1 here, so the greatest number of x plus 1s in a single denominator is 1. So that'd be our LCM, and we'll multiply both sides by that. Okay, so when we do that, this x plus 1 cancels this x minus 1 cancels this x minus 1. This x minus 1 cancels this x minus 1. This x plus 1 cancels that x plus 1. So we're left with 8 times x plus 1 is equal to 16. Now solve this. 8 times x is 8x. 8 times 1 is 8. That's a distributive property. Take the 8 over to the right side, and it becomes a negative 8. 16 minus 8 is 8. And then divide both sides by 8. And we get x equals 1 maybe. Let me double check myself here. Okay, 8x plus 8. Take that over as 8. Yeah, sure enough, it's 1. The reason why I'm questioning it is because that answer doesn't work. If I plug that back in my original problem, put 1 here, we get 8 over 1 minus 1. 1 minus 1 is 0, and you can't have division by 0. So the answer here is there is no solution. Okay, let's take a look at this problem. We got 3 over x plus 2 over x squared, 9 over x squared, minus 4 over x. Now, this is a complex fraction, fraction inside of fraction, and what you have to do is you have to figure out what your LCM is of all your inner denominators. Now, when I mean the inner denominators, I'm talking about the x squared here and the x down here. And for your inner denominators here, this would be this x and this x squared. Well, our LCM would be x squared. Since they're all x to a power, you choose the one with the largest power. So that's why it's x squared. And we're going to multiply everything by that. So we'll multiply it times our first fraction. We'll multiply it times our second fraction. We'll multiply it times the first fraction on the bottom. Minus, and then we'll multiply that times our last fraction of 4 over x. Now this x squared and this x cancels, leaving me 1x here, so that's going to give us 3x plus that x squared and that x squared cancel, leaves us 2. Down here, those x squareds cancel, leaves us 9. This x squared, one of these cancels this x, so that gives us a minus 4x. And what should my answer be written as? Doesn't say. That's nice. That bottom is not in standard form, but I'm guessing they don't want us to rewrite it, but we'll see if I get it wrong. 3x plus 2, 9 minus 4x. What if I can skip ahead? What are some of these? Looks like they're all rational functions. Okay, back to 6. I think I got the first 5 completed. Let's see. Yeah, I did finish that. Okay, so let's take a look at this one. We got 3a to the negative 1 over, plus 3a to the negative 1, a to the negative 1, plus 3a to the negative 2. First off, we can't have any negative exponents. So I'm going to take each one of those and create a fraction by putting them over 1. And we'll see why here in a minute. Now how we get rid of negative exponents is you take them opposite where they are in a fraction. So I'll take this a to the negative 1 and move it down below. Now I'll take this entire piece here, because all of this is the negative 1, and move it down below. Here I'll take this a to the negative 1, move it down below, and here I'll move this a to the negative 2, move it down below. So that's going to give us 3 over a to the first, plus 1. If you move everything and there's nothing left, you always put a placeholder of 1, over 3a to the positive 1. This becomes 1 over a to the first, plus 3 over a squared. So again, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So we'll have 3 over a plus 1 over 3a. Those first powers don't do anything. 1 over a plus 3 over a squared. Now we want to figure out what our LCM is of all our inner denominators. First off, I notice this one's got a 3, so 3 has to be part of it. Now this is a to the first, this is a to the first, this is a to the first, this is a squared. Remember, we'll go with the one with the largest power, so we'll go with a squared. So our LCM is going to be 3a squared. And we'll multiply that times 3 over a. We'll multiply that times 1 over 3a. We'll multiply that times 1 over a. And we'll multiply that times 3 over a squared. Now this a cancels with one of these a's, so it leaves me a single a. That 3 cancels that 3. This a cancels with one of those a's, so that's gone. This leaves me a single a. That a cancels one of those a's, so that cancels, and that leaves me a single a here. And these a squareds cancel. So let's see what we have left. 3 times 3 is 9, so we got 9a. Plus, what do I have left here? Just a times 1, which is a. Down here I got 3a times 1, which is 3a. And here I got, what, 3 times 3, which is 9. Let me double check that. 9a plus a, 3a plus 9. Well, I noticed the top I can factor a 9 out, but actually, let's factor a 9 out. And that gives me a plus 1. On the bottom I can factor a 3 out. And that gives us a plus 3. Now once I factor out GCF, notice that the 9 and the 3 will simplify. 9 divided by 3 is 3, so it leaves us 3 on top. A plus 1 over A plus 3. I'm assuming they don't want us to multiply that back through, but we'll see. 3 times A plus 1 and A plus 3. Okay, let me grab a drink. Let me clear this off. And it says, the intensity of light in foot candles varies inversely as the square of x. So here it looks like a variation problem. And it's specifically inverse is the type, because it says inverse. Now inverse is typically of the form y is equal to k over x. The intensity of light in foot candles varies is where your equals goes. So intensity of light, I'll put I for intensity, is equal to k over, varies inversely as the square of x. Now that would be x squared. And x is what? Distance in feet from light source. Now we need our one example. It says the intensity of light 2 feet away from the source. And x is distance in feet, so that would be our distance, I guess. So that's 2 squared. We put 2 in for x. The intensity of light 2 feet from the source is 20 foot candles. So I would be 20. Now we want to use this to solve for k. 2 squared is 4, and then I'll multiply both sides by 4. Those 4's cancel, and we got k is equal to 80. Now we know that, we're going to plug that back into our formula here. So we got I is equal to 80 over x squared. Now let's see what they really want. How far away, so that's what is x? Is the source of the intensity of light, how far away is the source that the intensity of light is 8 foot candles? So it's telling us I is 8. Now this is a rational equation at this point. Our steps for solving a rational equation would be to factor our denominators if we had to, but we don't have to. Multiply everything by the LCM of all your denominators. So multiply both sides by x squared. So we got 8x squared equals, these x squareds cancel, 80. Now I'm going to divide both sides by 8. And we get x squared is equal to 10. Now this is a square root property. You got something squared equal to something else, so you drop your squared and you put a plus or minus square root around the other side. And what does it say? Round to 2 decimal places. So square root of 10 to 2 decimal places would be 3.16. Now since x is a distance, probably the negative doesn't make any sense. So I'm just going to enter in the positive 3.16. And let's take a look at this problem. We have 2x to the third minus 16 over 6x squared plus 12x minus 48 times 9x plus 27 over 3x squared plus 6x plus 12. 2x to the third minus 16, 6x squared plus 12x minus 48, 9x plus 27, 3x squared plus 6x plus 12. Okay, and we want to multiply this. So we need to factor everything first. Now all of these appear to have GCFs. Both those divisible by 2. These are all divisible by 6. These are both divisible by 9. And these are all divisible by 3. So let's do that first. Here I'll factor 2 out, and that gives us x to the third minus 8. Here I'll factor 6 out, and that gives us x squared plus 2x minus 8. This one I'll factor a 9 out, and that gives us x plus 3. And here I'll factor 3 out, and that gives us x squared plus 2x plus 4. Okay. Now x to the third minus 8 makes me think difference of 2 squares, but it doesn't work, so I go to difference of 2 cubes. So I write sloppy enough you can't see what in the world I'm writing. Try to write it small, but that's difference of 2 cubes. That's nothing. This is PSD, I believe. And this I don't think factors, so it doesn't break down any. I would try PSD, but I'm pretty sure it doesn't factor. Now, difference 2 cubes, that factors as x minus 2 times x squared plus 2x plus 4. And this down here, this factors as x plus 4 times x minus 2. And everything else carries down. Now let's see what can cancel. X minus 2 cancels that x minus 2. This x squared plus 2x plus 4 cancels this x squared plus 2x plus 4. 2 and 6 are both divisible by 2. Goes to 1. 6 divided by 2 is 3. Do I have anything else to cancel? Oh, the 9 here, or the 9 and 3 here. 3 divided by 3 is 1, 9 divided by 3 is 3. And actually then I see I have a 3 here and a 3 here. Those are going to cancel. So what in the world's left on top? Okay, x plus 3 I guess. That's gone. What's left on the bottom? X plus 4. So that'd be our answer. So we got x plus 3 over x plus 4. Let's take a look at this problem. This is x squared minus 25 over 5 minus x. And we want to simplify it. Well, the top part is the difference of 2 squares, 2 terms of minusing it. The bottom part is wrong order. It's not in standard form. So top part factors as x plus 5, x minus 5. And the bottom, I'll rewrite it, putting the negative x first and then the 5 second. Now once I rewrite it, this is now GCF. Reason why is because my first term is negative. So we're going to have x plus 5, x minus 5 over, factor a negative 1 out, and that gives us x minus 5. Now at this point, these x minus 5s cancel. And I'm left with x plus 5 over negative 1. Now if I divide both those by negative, that gives me a negative x minus 5. Assuming they write their answer in that form. Sometimes they factor the negative out. And let's take a look at this problem. I want to factor or find the LCD of the rational expressions. So I'm going to clear this all off. Then we got 2t over t squared minus x squared. And we got 7 over t squared minus 2tx plus x squared. Well, to find the LCD, we need to factor each one of our denominators. So we got t squared minus x squared. Actually, I guess I could do it right within the fraction. This is difference of two squares, two terms of the minus tangent. This would be PSD, because we got t squared, t, no t, and there's no number from our t squared. So this becomes 2t over t plus x times t minus x. This one becomes t minus x times t minus x. Now our LCD. We take a look at each factor. For example, I start with the t plus x. Now I'm looking for the greatest number of t plus x's in a single denominator. There's one here, there's none here, so the greatest number of t plus x's in a single denominator is 1. Then I go to my next factor, which is t minus x. Now I'm looking for the greatest number of t minus x's in a single denominator. There's one here, there's two of them here, so we would have two of them. And they probably write that as squared, so we're going to have t plus x, and we'll have t minus x squared. Okay, so t plus x and t minus x squared. Take a look at this problem. This is probably my least favorite chapter of the book. I don't like rational expressions. That's why I was looking through the test to see if it's all rational expressions, and it was. I just find them tedious. I don't find them necessarily hard, just tedious. Now, when you're subtracting rational expressions, you got a minus, a negative out in front of the fraction. That flips the sign of everything up on top. So, flip sign of the x and of the 7. Other than that, if they have the same denominator, we're merging these into a single fraction. So we're going to have x minus 7, and then change the positive x to a negative x, and change the positive 7 to a negative 7 over 2x. Then x minus x cancels. Negative 7 is negative 14 over 2x. Now the 14 is divisible by 2, so 14 divided by 2 is 7, so we're going to have negative 7 over x. Of course, also a big part of it is, we'll see how many I get wrong. I may not like them at all at that point. I'm assuming I'm not making any mistakes. Nobody's pointed it out to me. Bizarre sense of humor, I know. Okay. X over x squared minus 4 plus 2 over x squared minus 4x plus 4 minus 1 over x plus 2. Now notice that all of these, assuming I wrote them down correctly, all of these have different denominators. So we have to get a least common denominator. And how we do that is we factor all of our denominators. This is difference two squares, this is PSD, and this last one's nothing. It's already factored as much as it can be. So this factors as x over x plus 2, x minus 2, plus 2, and this factors as x minus 2 times x minus 2, minus 1 over x plus 2. Now to find our least common denominator, we start with our first factor, the x plus 2. Now I'm looking for the greatest number of x plus 2's in a single denominator. There's one here, none here, one here. So the greatest number of x plus 2's in a single denominator is 1. Now I go to my next factor, the x minus 2. And I'm looking for the greatest number of x minus 2's in a single denominator. There's one here, there's two of them here, and there's none of them here. So the greatest number of x minus 2's in a single denominator is 2 of them. So this is going to be our least common denominator. So I'm going to rewrite each fraction with that new denominator. Now we have to figure out what the new item is down below. And why did I put a minus there? Or a plus? That would have been a mistake. Minus. Okay, let's look at our old fraction. We had x plus 2. We still have the x plus 2. I don't know why I'm saying new. We have x plus 2. We still have the x plus 2. We have the x minus 2. We still have the x minus 2. The new item in our first fraction is an x minus 2 here. So whatever you put on the bottom, you have to put up on top. The mathematical principle behind that is whatever you multiply by the bottom, you have to multiply by the top. Now our second fraction, we had an x minus 2. That x minus 2 is still there. We had another x minus 2. That x minus 2 is still there. So the new item down below that we just put is x plus 2. So whatever you put on the bottom, you have to put on top. Our last fraction, we had an x plus 2. That x plus 2 is still there. So our new item is the x minus 2 and the other x minus 2. Okay, so let's I'm not going to write down the denominator because it's the same, but I'm going to multiply these together on top. X times x is x squared. X times negative 2 is negative 2x. And I'll put a squiggly here for our old denominator. We'll eventually put that back in. Then we got 2 times x, which is 2x, 2 times 2, which is 4, over squiggly, minus, that 1 is trivial, that drops away, I'll FOIL this. That gives us x squared minus 2x minus 2x plus 4 over squiggly. Okay, so we're going to have, I'm going to go ahead and merge this all into one fraction. So we got x squared minus 2x plus 2x plus 4. Remember, a negative out in front of your fraction flips the sign of everything inside. So the x squared becomes a negative x squared. The negative 2x becomes a positive 2x. The negative 2x becomes a positive 2x. And the positive 4 becomes a negative 4. And our denominator is still the same, hasn't changed, squiggly. Combine like terms. Here's an x squared minus x squared. Those cancel. Negative 2x plus 2x. Those are going to cancel. And here we got 2x plus 2x. That gives us 4x. And number-wise, what do we have number-wise? 4 minus 4. That cancels. That's interesting. Now put our denominator back in. X plus 2. And x minus 2 times x minus 2, probably they'll want the answer as x minus 2 squared, because there's 2 of them. So 4x over x plus 2, x minus 2 squared. Let me clear that off. So we got c of x is equal to x minus 3 over x squared minus 9. Now the instructions say find a domain. Well, to find our domain, you set your denominator equal to 0 and you solve it. Now this factors as x plus 3 times x minus 3, difference 2 squares. We then set each factor equal to 0. So we got x plus 3 equal to 0, and we got x minus 3 equal to 0. And that gives us negative 3, and that gives us positive 3. Now these are the values we cannot have. These, if we plug them back into our original problem, cause the denominator to equal 0. So x cannot equal to negative 3, and it cannot equal to 3. Now let's see how they want us to write the answer, though. They actually use a not equal here. Okay, type your integer, use a comma. So it can't be negative 3 or 3. I was hoping it wasn't interval notation. Okay, let's take a look at this one. We got y is equal to 1/3 when x is equal to 6. Find the constant of variation. If y varies inversely as x. I was thinking we were missing something. What that means is y is equal to k over x. Inverse is always of this form. So we want to find k. So they give us our one example. So we'll plug 1/3 in for the y equals k over x, which is 6. Now I want to solve for k, so I'm going to multiply both sides by the LCM of all your denominators. 3 and 6, the LCM would be 6. So I take 6 times 1/3, 6 times k over 6. No 6's cancel, and I got k equals 6 divided by 3 is 2. 2. Now it says find the inverse equation given y is equal to 1/3 and x equals 6. That's the same as above. So now that we know what k is, this becomes, when I say this becomes, I'm talking about this formula, y is equal to 2 over x. Over x. Okay, let me grab another drink. Now in this problem, tells us f of x is equal to 6 over x plus 1. Gives us a little bit of background. It says in study of calculus, difference quotient is often found and simplified. Find and simplify this quotient for the function f of x and complete all the different parts. First thing it tells us to find is f of a plus h. This is just evaluating. So we're going to go to our function, and where our x was, we'll put in parentheses. Now evaluating a function is always the same. Whatever's inside this parentheses right here is automatically what we're going to put in right here. So I'll put in a plus h. Now to simplify that, those parentheses actually aren't doing anything. So this is 6 over a plus h plus 1. So 6 over a plus h plus 1. Now B says find f of a. Well, this is still evaluating. We go back to our original function. Where x was, we put in parentheses. And evaluating is always the same. Whatever's inside this parentheses is automatically what you put here. So put the a in there. So this is 6 over a plus 1. Over a plus 1. Now it says we want to now find f of a plus h minus f of a over h. So we're going to plug in what we just found. So this is 6 over a plus h plus 1. That's my f of a plus h, minus f of a, which we said was 6 over a plus 1, all over h. Okay, so I'm going to click here, do my fraction, and then within that I have another fraction, so I click my fraction again. 6 over a plus h plus 1, minus another fraction, 6 over a plus 1 over h. Now D wants us to simplify this. Now simplify it is kind of a strange instruction. It basically means get rid of the h in the denominator. Along the way we're going to accomplish some other items. Now we have some inner denominators because we got a fraction inside of a fraction. So our LCM of the inner denominators would be these two multiplied together. So that's what we're going to multiply everything by. So we'll take a plus h plus 1, a plus 1, multiply that times our first fraction, the 6 over a plus h plus 1, minus 6 over a plus 1 times a plus h plus 1 times a plus 1, all over h times a plus h plus 1 times a plus 1. This a plus h plus 1 cancels this a plus h plus 1. This a plus 1 cancels this a plus 1. So then we're left with, up on top, 6 times a plus 1 minus 6 times a plus h plus 1 over h times a plus h plus 1 times a plus 1. Now, typically we don't multiply the bottom part together because we're hoping that h will cancel, and we don't want to convolute it by putting h mixed into a lot of different things. Now, when I say the h, I'm talking about a single h. But on top, I'll use a distributive property. 6 times a is 6a. 6 times 1 is 6. Negative 6 times a is negative 6a. Negative 6 times h is negative 6h. And negative 6 times 1 is negative 6, all over h, a plus h plus 1, and a plus 1. Now up on top, 6a minus 6a cancels. 6 minus 6 cancels. Looks like we're left with a negative 6h. I don't know if that's true or not. Let me see. Okay, those are gone. These are gone. That is true. Then h times a plus h plus 1 times a plus 1. Now that I've done that, up on top we got negative 6 times h. So since that's multiplication, that h down there will cancel with this h here. So we're going to have negative 6 over a plus h plus 1 times a plus 1. So we got negative 6 over a plus h plus 1 times a plus 1. Division. Okay, let me clear this off. To try and remember what kind of division we covered, I guess I'll do it both ways. So I'm going to use long division. I'll also use synthetic division, in case we covered that. The reason why this one would work in either case is because we have x plus or x minus a number out in front. If you're dividing by something of that form, you can use either one. Now, if you had an x squared here, or if you had a number in front of the x, you'd have to use long division. Okay, so we'll take a look at the first term of each side, what goes up on top. You ask yourself what times x gives you 3x squared, and that'd be 3x. Now, whatever you put up on top, you multiply by what's on front. 3x times x is 3x squared. 3x times negative 5 is negative 15x. Now we want to subtract that line, which means we flip signs. 3x squared minus 3x squared drops away. Negative 22x plus 15x gives us negative 7x. And then I'll bring down the plus 35. Now again, we look at the first term of each side, what goes up on top. You ask yourself what times x gives you negative 7x, and that's negative 7. Whatever you put up on top, you multiply by what's on front. Negative 7 times x is negative 7x. Negative 7 times negative 5 is 35. Now we're going to subtract that. So we'll flip signs. So that becomes a plus, and that becomes a minus. And we get 0. So our answer is 3x minus 7. And I guess I won't show synthetic division. Although if you do know synthetic division, you can use it on this one. Okay, now we want to subtract these. So let's take a look at this problem. So we got y plus 7 over y squared minus 7y plus 10 minus 7 over y squared minus 25. Now they don't have a common denominator, so that's what I have to work at getting first. And first thing we'll do is factor the denominators. This is PSD, and this is dots. So this one factors as y plus 7 over y minus 2 and y minus 5 minus 7, and this one factors as y plus 5, y minus 5. So to figure out our least common denominator, we'll take a look at each factor. Start with the x minus 2. Now I'm looking for the greatest number of x minus 2's in a single denominator. There's one here, none here. So greatest number of x or y minus 2's in a single denominator is 1. Then I go to y minus 5, and I'm looking for the greatest number of y minus 5's in a single denominator. There's one here, there's one here, so the greatest number of y minus 5's is 1. And then I go to y plus 5, and I'm looking for the greatest number of y plus 5's in a single denominator. None here, one here, so it'd be 1. So that's going to be our least common denominator. Now we have to look at what's new on these. This had a y minus 2, this has a y minus 2. This has a y minus 5, this has a y minus 5. The new item down below is the y plus 5, so we have to put that up on top. Mathematical principle is whatever you multiply by the bottom, you have to multiply by the top. Here we have y plus 5, that y plus 5 is still there. Here we have y minus 5, that y minus 5 is still there. The new item down below is the y minus 2, so we have to put that up on top. Now I'm going to multiply these together on top. Y times y is y squared. Y times 5 is 5y. 7 times y is 7y. 7 times 5 is 35. And I won't write down my denominator yet because they're the same now, so I'll just put squiggly there. Minus distributive property. 7 times y is 7y. 7 times negative 2 is negative 14. Over squiggly. So I'm going to merge these into a single fraction since they have the same denominator. So I'm going to have y squared plus 5y plus 7y plus 35. Now remember, a negative out in front of your fraction flips the sign of everything up on top. So flip the sign as 7y and negative 14. So a positive 7y becomes a negative 7y, and a negative 14 becomes a positive 14. All over our denominator. Combine like terms, we got y squared. 7y minus 7y cancels, now leaves us 5y. And 35 plus 14 is 49. Uh, 5y, 35 plus 14, 45, 49. 1 times 49 is 7 times 7. Okay, that doesn't factor. So I'm going to go ahead and put my denominator back in. Y minus 2, y minus 5. For some reason I was thinking this is gonna cancel the way it was starting to be set up. Assuming I didn't make a mistake. Okay, so we got y squared plus 5y plus 49 over y minus 2, y minus 5, and y plus 5. And let's take a look at this one. Let me clear this off. And we got x over x plus 2 minus x over x minus 2 divided by x over 6x plus 12. First off, order of operations says do what's inside the parentheses. And I notice I got subtraction in here, so we have to get a common denominator. Now, these denominators we can't factor, so our common denominator is just going to be the two multiplied together. Now the new item. In our first fraction, we had an x plus 2. That x plus 2 is still there. The new item we put up on top is x minus 2. On our second fraction, had an x minus 2. The x minus 2 is still there. The new item we put on the bottom is the x plus 2. So you have to put that up on top. And then divided by x over 6x plus 12. Now I'm going to multiply the top part. X times x is x squared. X times negative 2 is negative 2x over our denominator. Minus x times x is x squared. X times 2 is 2x over our denominator. Divided by x over 6x plus 12. Well, now that they have the same denominator, I can merge these into a single fraction. So we got x squared minus 2x. Remember, a negative in front of your fraction flips the sign of everything on top. So the x squared becomes a negative x squared. The 2x becomes a negative 2x. Divided by x over 6x plus 12. Now the x squared minus x squared cancels. Negative 2x is negative 4x over x plus 2, x minus 2. Now, division. I know I'm going to rewrite that as multiplication, and I flip the second fraction. So this becomes 6x plus 12 over x. Now I want everything factored, and the only thing that isn't factored is the 6x plus 12. I can factor 6 out of that. So we're going to have negative 4x over x plus 2, x minus 2, times, factor 6 out, and that gives us x plus 2 over x. Now this x plus 2 cancels this x plus 2. This x cancels this x. What do I have left? Negative 4 times 6 is negative 24, and on the bottom I have an x minus 2. So that looks like that'd be our answer. So negative 24 over x minus 2. Let's, oh, here's synthetic division. I guess we did cover that. It's a Sunday morning. I stayed up a little bit too late last night working. Like to say I was out having fun, but I'm too old for that kind of stuff. So we got x to the third plus 3x squared minus 5x minus 15 over x minus 3. Okay. First step in synthetic division is you take your denominator, you set it equal to 0, and you solve it. So that gives us x equals 3. We then take that number we just found, we put it in a box in the upper left-hand corner, and we identify our largest power, which is x to the third. So real small across top, I'm going to write x to the third, x squared, x, and no x. And write down the number that's in front of each one. There's an invisible 1 in front of the x to the third, there's a 3 in front of the x squared, there's a negative 5 in front of the x, and there's a negative 15 at the end. Now I'll go through a series of adding, multiplying over and over until I'm done. 1 plus nothing's 1. You always multiply by a number in a box. So 3 times 1 is 3. Put it here. Add. 3 plus 3 is 6. Multiply. Take the number in a box times the number I put down there. 3 times 6 is 18. Add. Negative 5 plus 18 is 13. Multiply. 3 times 13 is 39. And add. And that gives us, what does that give us? 24? 1, 3, 6, 18, 13, 39, 24, yeah. Okay, so this was x to the third. Straight down below will be 1 degree lower. So that'll be x squared, this will be x, this will be our no x, and this is our remainder. So our answer is x squared plus 6x plus 13, and you put your remainder over what you're dividing by, which was x minus 3. Do not factor. I don't know what that means. I don't think it can factor. Plus 24 over x minus 3. X squared plus 6x plus 13 plus 24 over x minus 3. Add or subtract is indicated. So let's subtract this. Let me clear this off. And we got 4 over x squared minus 9 minus 2 over x squared plus 6x plus 9. Now we have to get a least common denominator. In order to figure out what that is, we have to factor all of our denominators. This one is the difference of two squares. This one is PSD. So this factors as 4 over x plus 3, x minus 3, minus 2, and this one factors as x plus 3 times x plus 3. Now we have to figure out what our least common denominator is. So we'll start with our first factor, the x plus 3. Now I'm looking for the greatest number of x plus 3's in a single denominator. There's 1 here, there's 2 here. So the greatest number of x plus 3's in a single denominator is 2. Then I go to my next factor, the x minus 3. I'm looking for the greatest number of x minus 3's in a single denominator. There's 1 here, none here, so the greatest number of x minus 3's is 1. So that's our least common denominator. Now we have to figure out what new item goes down below. Here was an x plus 3, here's an x plus 3, here's an x minus 3, here's an x minus 3. The new item is another x plus 3. So we have to put that up on top. And over here, x plus 3, x plus 3, x plus 3, x plus 3. The new item down below is the x minus 3. So we have to put that up on top. Now multiply these together on top. 4 times x is 4x, 4 times 3 is 12, and I'll put a squiggly for my denominator because they're the same now. 2 times x is 2x, 2 times negative 3 is negative 6, over squiggly. Now I'm going to merge these into a single fraction. So I'm going to have 4x plus 12. Remember, a negative out in front of your fraction flips the sign of everything on top, so it becomes a negative 2x plus 6, over squiggly. 4x minus 2x is 2x, 12 plus 6 is 18, over squiggly. Now I can factor a 2 out of the top, and that's going to give us x plus 9, and then I'll put my denominator back in. Now I'm going to put the x minus 3 first, and then the x plus 3 is x plus 3 times x plus 3, so that's x plus 3 squared. Okay, so this is x plus 9. And down here we got x minus 3, x plus 3 squared. And let's take a look at this problem. So we got Q is equal to FV over F plus V. And it says solve the equation for V. So we want to solve it for V. First step. This is solving a formula for a variable. First step is get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so we're going to multiply both sides by F plus V. Now I'm going to do that. These F plus V is going to cancel over here. Q times F is QF. Q times V is QV equals FV. Third step, get everything with the variable you're solving for on one side, everything else on the other side. So I'm going to take this QV over to the right side. So I got QF is equal to FV minus QV. Now step 4 is factor out the variable you're solving for if possible. And I said you'll have 2 or more of that variable. Well, we have 2 v's, so that means I can factor out a v. And that gives us f minus q. And then last step is to divide both sides by what's in front of / back of the variable you're solving for. Nothing in front of the v, but there's an f minus q after it. So I divide both sides by f minus q. And do that, those f minus q's cancel. And we got v is equal to qf over f minus q. So simplify your answer. What does that mean? It's simplified as much as it can be. qf over f minus q. And let me clear this off. Weight of a synthetic ball varies directly with its cube of its radius. So direct variation, weight of a synthetic ball. So W for weight varies directly, so K times something, with the cube of its radius. So R to the 3rd power. A ball with a radius of 2 inches, the cube of its radius. It doesn't say what measure, so R is 2. This is our one example. Weighs 0.80 pounds. So this is 0.80. Now 2 to the 3rd is 8, so that gives us 8k. And then if I divide both sides by 8, that gives us, not very good decimals, but I think that's 0.1. So now this formula here becomes W is equal to, I'll put a 0 there, 0.1 R to the 3rd. Now let's find what they really want. Find the weight. So we want to find W. Of the ball, weight of a ball with the same material with 3-inch radius. So R is 3. So we got 3 to the 3rd. 3 to the 3rd is 27 times 0.1 is 2.7, I think. But let me check. I'm not very good at decimals. 0.1 times 27. 2.7. And answer-wise, what does this say? Decimals? Type an integer or a decimal. So it'd be 2.7 pounds. Okay, I'm going to grab a drink here. Okay. We'll clear this off. And we got Q is equal to R minus U over L. And I want to solve it for U. Okay, first step is to get rid of parentheses. Don't have any. Second step is to get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, which is L. So I'll multiply both sides by L. Do that. These L's cancel. And this is LQ is equal to R minus U. Now I'm trying to solve for U. So our next step, get everything with the variable we're solving for on one side, everything else on the other. I'm going to take this negative U and move it to the left side, and this LQ to the right side. So we got U is equal to R minus LQ. So U is equal to R minus LQ. I kind of cringe every time I see one of these, but sometimes it takes me a while to get word problems myself. Local dairy has 3 machines to fill half-gallon milk cartons. The machine can fill a daily quota in 6 hours, 5 hours, and 8.5 hours, respectively. Find out how long it takes to fill a daily quota if all 3 machines are running. Okay, I think this is a shared work problem. So we'd have 1 over x is equal to 1 over 6 plus 1 over 5 plus 1 over 8.5. Now the 1, assuming I'm reading it correctly, the 1 refers to our quota, 1 quota. And this is a shared work. This is how long it took machine 1, 6 hours. This was 1 over 5. This is 1 over 8.5. And so they're working together to achieve this. We're still finishing a quota of 1. And we're trying to figure out how long it'll take. Now I'm going to cheat a little bit. I don't like working with fractions. Hopefully if you don't have a TA3, TA4, you at least have a scientific calculator. So 1 divided by 6 plus 1 divided by 5 plus 1 divided by 8.5. And then I'll do inner and then math, inner. 247 over 510. Now I could cross multiply here, solve with proportions, but I'm going to go through my rational equations, multiply everything by the LCM of all your denominators, which x times 510 would be 510x. So multiply that times the 1 over x. We'll multiply that times the 247 over 510. So these x's cancel, these 510's cancel. So 510 times 1 is 510 equals 247 times x is 247x. Now I divide both sides by 247. And what do they want? Probably not a fraction. Round to the nearest hundredth. So 2 decimal places. So 510 divided by 247. 2.06. It takes 2.06 hours to fill a quota if all my 3 machines are running. Another word problem. Being punished. In a recent year, 4 out of 7 movies cost between 50 and 99 million to make. At this rate, how many movies in a year would you predict the cost between to make? $519 new releases. Okay, well, I think it's a rate of change, since we're asking how many new releases. Then see, what do we want? We want dollars over new releases. Now if I think of this as a change in Y over the change in X, that means X is our new releases. So I'm reading it wrong. This just simply says 4 out of 7 movies cost between this. So that means 4/7 of the movies cost between 50. At this rate, how many movies in a year with 519 releases? That's interesting. So 4 out of 7 times 519? That doesn't seem right. I could pretty well guess that one's going to be counted wrong. I'll blame the sun being in my eyes. Actually, I'm getting a headache from all these rational expressions. That's my excuse. Okay, approximately round to the nearest whole number. So if I round up, that's 297. That seems too easy, so I know I'm doing something wrong because this isn't an easy chapter. Okay, write the statement as an equation. Use k as a constant variation. R varies jointly. So k jointly is m and the square of n. So n squared. Jointly is m and the square of n. Okay. Solve this equation. So we got 6 over v plus 1 over 5 is equal to 9 over v. Now this is a rational equation, so we'll factor all of our denominators if we could. Can't factor. We'll find the LCM of all our denominators, which would be 5v. It's not v squared because we're looking for the greatest number of v's in a single denominator. There's one here, so that's why we only have one. So we'll multiply that times 6 over v. We'll multiply that times 1 over 5. And we'll multiply that times 9 over v. Those v's cancel, these v's cancel, these 5's cancel. 5 times 6 is 30, plus v times 1 is v. 5 times 9 is 45. Now take 30 over. It becomes a negative 30, and that gives us v is equal to 15. Divide. Okay, this doesn't say anything about technique, so I'm going to use synthetic division. So we got 3x to the third minus 9x squared minus 7 divided by x minus 5. The reason why I can use synthetic division is because it's x minus a number. So first step, we'll set the x minus 5 equal to 0 and solve, and we get x is equal to 5. We then put that number in the box in the upper left-hand corner. We identify our largest power, which is x to the third. So real small across top, I'll write x to the third, x squared, x, and no x. The number that's in front of our x to the third is a 3. The number in front of our x squared is a negative 9. There is no number in front of our x, so that's 0. And our no x, our constant term, is negative 7. So add, 3 plus nothing is 3, multiply, 5 times 3 is 15, add, negative 9 plus 15 is 6, multiply, 5 times 6 is 30, add, 0 plus 30 is 30, 5 times 30 is 150, and that gives us 143. Okay. This was x to the third, this is 1 degree lower, so that's x squared, this is x, this is our no x, and this is our remainder. So our answer will be 3x squared plus 6x plus 30, and we take our remainder, which is 143, and divide by and over what we're dividing by. So 3x squared plus 6x plus 30 plus 143 over x minus 5. The sum of the reciprocals of two consecutive integers. Okay, first off, consecutive integers, that's like x is 1. And consecutive, that'd be x plus 1. That's our second. The reciprocal of those, well, if I put in fraction form, that's x over 1, and this is x plus 1 over 1. So reciprocal will be 1 over x. Reciprocal means fraction flipped, and this would be 1 over x plus 1. And the sum of those, so I'm going to have 1 over x plus 1 over x plus 1 is equal to 17 over 72. Well, I'm going to multiply everything by the LCM of all our denominators, which would be 72x, x plus 1. So multiply that times 1 over x. We'll multiply that times 1 over x plus 1. And we'll multiply that times 17 over 72. So these x's cancel, these x plus 1's cancel, these 72's cancel. The 1's trivial, that drops away. 72 times x is 72x. 72 times 1 is 72. Here, 72x times 1 is 72x. And over here, 17 times x is 17x, and 17 times 1 is 17. 72 plus 72 is 144x plus 72 is equal to 17x plus 17. Get everything with an x on one side, numbers on the other side. So I got 144x minus 17x is equal to, this isn't looking good, 17 minus 72. So I think it said they're integers, didn't it? Yeah. Well, let's continue. I don't think it's right. 144 minus 17. 127x. 17 minus 72. Negative 55. Divide both sides by 127. And we definitely don't get an integer. Okay, let me see. Sum of the reciprocals of two consecutive integers. Sum of the reciprocals. X plus 1. That'd be 1 over x. That'd be 1 over x plus 1. The sum, that's add, is equal to 17 over 72. Okay, multiply everything by 72x, x plus 1, 72x, x plus 1, 72x, x plus 1. Those x's cancel. We got 72 times x, 72 times 1, 72. Those x plus 1's cancel. That gives us 72x. Over here, the 72's cancel. Ah, I see where I screwed up. There's an x here. So that's 17x times x plus 1. Okay, so that gives us 144x plus 72 equals 17x times x is 17x squared. 17x times 1 is 17x. That's a quadratic, so I want to get everything over on one side, so I'll move those over to the right side. So I got 17x squared plus 17x. The 144 becomes a negative 144x, and the 72 becomes a negative 72. 17 minus 144. Negative 127x minus 72. I hope those are all divisible by 17. So, what are my signs? Okay, this is a negative. Signs will be different. This is a negative, so this should be a negative. Well, I shouldn't say that. Signs are different. 1 and 72, 2 and 36. What a horrible problem. 17 times 72. That gives us 1,224. So if I do all my products, 1 times 1224, 2 times 6, 1, 2. 3, 4, 8, yeah, 3 times something. 408, 4 times something. 306, 4, 5, 6 times something. 204, 7, I don't know. 1224 divided by 7. 1224 divided by 8. There it is. Or no, well, 8 times 153. No, that's not it. 1224 divided by 9. It's not divisible. Oh, yeah, it is. Okay, 9 times 136. And 136 subtract 9 gives us 127. There it is. Okay, so we're going to use grouping. I mean, key number. So this becomes negative 136x plus 9x minus 72. I'll factor out GCF. 17x. And that gives us x minus 8. Here I'll factor a 9 out, and that gives us x minus 8. They both have an x minus 8, so I'll factor that out. And I need an integer, so I don't need to set this equal to 0. I'll just set the x minus 8 equal to 0. And we get x is equal to 8. So if that's our first one, the second one will be 9. Well, that's as unpleasant as could be. Use a comma to separate the answers. 8, 9. Let's take a look at this problem. We're expected to go somewhere today. I'm surprised my wife isn't hollering at me that we're getting ready to leave. Maybe I'm just hoping for a call to end this nightmare. Like I say, I can do these, but they're just tedious. This is a complex fraction, and we want to simplify it. So we want to factor all of our inner denominators. The x squared minus 9 is the difference of two squares. So this is x minus 2 over x plus 3, x minus 3, all over 1 plus 1 over x minus 3. Now our inner denominators are the x minus 3 and the x plus 3, x minus 3. So we want to multiply everything by the LCM of all our inner denominators. I start with my first factor, the x plus 3, and I'm looking for the greatest number of x plus 3's in a single inner denominator. There's 1 here, none here, so we're going to have 1. I go to my next factor, which is x minus 3, and I'm looking for the greatest number of x minus 3's in a single inner denominator. 1 here, so it'll be 1. So we're going to multiply that times the top. We'll multiply it times the 1. And we'll multiply it times this last fraction. So then this x plus 3 cancels that x plus 3, this x minus 3 cancels that x minus 3, this x minus 3 cancels that x minus 3. Let's see what we have left. Up on top we got x minus 2, and on the bottom, that 1 is trivial, that drops away, and I'm going to multiply this together. I'm going to FOIL it, I'm going to skip a few steps. That's x squared minus 9. I really do want to finish this before I have to go. And then x plus 3 times 1 is x plus 3. So that gives us x minus 2 over x squared plus x minus 6. And the bottom factors as PSD. So this factors as x plus 3 times x minus 2. And notice that the x minus 2's cancel. So we're going to be left with 1 over x plus 3. I want to solve this equation. So we're going to have x squared minus 3 over 2x squared minus 10x plus 12 plus negative 3 over x minus 3 equals 3 over 2x minus 4. Okay, so we're going to have to factor all of our denominators because we need to find the LCM of the denominators so we can multiply everything by it. This is GCF. They're all divisible by 2. This is GCF. They're both divisible by 2. So we're going to have x squared minus 3 over, factor a 2 out, and that gives us x squared minus 5x plus 6. This minus I'll put out in front. And this one I'll factor out a 2, and that gives us x minus 2. Now this factor is using a PSD. So we got x squared minus 3 over 2 times x minus 2, x minus 3. Minus 3 over x minus 3 is equal to 3 over 2 times x minus 2. Now we want to multiply everything by the LCM of all the denominators. Well, this first fraction has a 2 here and 2 here, so I need a 2. Now the x minus 2, I'm looking for the greatest number of x minus 2's in a single denominator. There's 1 here, none here, 1 here, so I'm going to have 1. And we're just going to have 1x minus 3. Same reasoning. Multiply that times our first fraction. We'll multiply it times our second fraction. And we'll multiply it times the fraction on the right side. That 2 cancels that 2. This x minus 2 cancels that x minus 2. This x minus 3 cancels that x minus 3. This x minus 3 cancels that x minus 3. This 2 cancels that 2. This x minus 2 cancels that x minus 2. So what in the world are we left with? Over here we're left with x squared minus 3 minus 3 times 2 times x minus 2 equals 3 times x minus 3. Let me double check that. Okay, x squared minus 3 times 2 x minus 2 equals 3 times x minus 3. Okay, so we got x squared minus 3. Negative 3 times 2 is negative 6 times x minus 2 equals 3x minus 9, distributive property. X squared minus 3, negative 6 times x is negative 6x. Negative 6 times negative 2 is 12. And I'll bring these two over to the left side. That becomes a negative 3x plus 9. So we got x squared, combine like terms. Negative 6x, negative 3x is negative 9x. Negative 3 plus 12 is 9, plus 9 is 18. And that factors, using the PSD, as, what does it factor as? X minus 3 times x minus 6. Zero factor property, set each factor equal to 0. So I'll set x minus 3 equal to 0 and x minus 6 equal to 0. And that gives us 3 and that gives us 6. Now, the problem is when I put 3 back in my original problem, it causes one of the denominators to equal 0. But the x equals 6 is okay. If I plug that in, I don't see anywhere it causes an issue. So our answer is x equals 6. Oh, great. Another plane. Or another word problem. A plane flies 465 miles with the wind and 315 miles against the wind, same length of. Find the speed of the plane in still air. So I think that'd be 465, and I'm not sure if I'll set this up right. Equals 315. Speed of the wind is 25 miles per hour. Okay, with the wind. With the wind means you should go faster. So I think this will be x plus 25, and this would be x minus 25. If it's against the wind, you should be going slower. Now I'm going to go ahead and cross multiply, just to save time. So 465 times x minus 25 equals 315 times x plus 25. So I got 465x minus 460, I got my calculator right here. 465 times 25. Now if this doesn't give us the correct answer, assuming I set that up right, this part I'll probably have to look up. I'm not very good with these with the wind and against wind problems. 315 times 25. 78.75. Okay, right away I notice that oh no, never mind. 465x, bring the 315 over, and take the negative 11,625 over, becomes a positive 11,625. 465 minus 315 gives us 150x. 78.75 plus 11,625, 19,500. Divide both sides by 150. 130. So let's see if that's what they're asking. Find the speed of the plane in still air. Okay. So 130, hopefully. Take a look at this problem. Use a remainder theorem. So we wanted to evaluate this. So remainder theorem says we plug that into synthetic division. Now our largest power is x to the fourth. So real small across top we'll have an x to the fourth, an x to the third, an x squared, an x, and a no x. Number in front of our x to the fourth is a 7. There is no x to the third, so that's 0. This is negative 2. Number in front of our x squared. There is no x, and then negative 1. So I'll add 7 plus nothing, 7. Multiply. 1/2 times 7 is 7/2. Add 0 plus 7/2 is 7/2. Multiply 1/2 times 7/2 is 7/4. Add, and I'm going to cheat and use my calculator. I think it's negative 1/4, but plus 7 divided by 4. Math inner, negative 1/4. 1/2 times negative 1/4 is negative 1/8. Add, that gives us negative 1/8. Multiply, 1/2 times negative 1/8 is negative 1/16. And add, negative 1 minus 1 divided by 16. Math inner, negative 17/16. Simplify your answer. Okay, negative 17 over 16. Last problem. Got 16 over x squared minus 4 plus 1 is equal to 2x over x minus 2. Now, we're solving this, so we're going to factor all of our denominators. This will be the difference, two squares, two terms minusing it. So this becomes 16 over x plus 2, x minus 2, plus 1 equals 2x over x minus 2. Now we want to multiply everything by the LCM of all our denominators. Start with our first factor, the x plus 2. I'm looking for the greatest number of x plus 2's in a single denominator. There's 1 here, none here. So the greatest number of x plus 2's is 1. Now the x minus 2. I'm looking for the greatest number of x minus 2's in a single denominator. 1 here, 1 here. So the greatest number of x minus 2's in a single denominator is 1. So that's our LCM. And that's what we'll multiply everything by. Multiply by 16 over x plus 2, x minus 2. We'll multiply it times the 1. And we'll multiply it times the fraction on the right side. Okay, that x plus 2 cancels that x plus 2, this x minus 2 cancels that x minus 2, and over here this x minus 2 cancels that x minus 2. So we're left with 16 plus, I'm going to FOIL this, x times x is x squared, and then minus 4. Over here 2x times x is 2x squared, and 2x times 2 is 4x, distributive property. So then we'll have x squared, 16 minus 4 is 12. Is equal to 2x squared plus 4x. Get everything over on one side, so I take the 12 and move it over, and I take the x squared and move it over. So that gives us 2x squared minus x squared plus 4x minus 12. 2x squared minus x squared is x squared plus 4x minus 12. And if the factors will be PSD, my brain's shutting down. 1 times 12, 2 times 6, yeah. X plus 6 and x minus 2. Now, set each one of those equal to 0. So we got x plus 6 equal to 0 and x minus 2 equal to 0. And we got x equals negative 6 and x equals positive 2. Except the x equals positive 2 causes the denominator to equal 0. 2 minus 2 is 0. So our only answer is x equals negative 6. Okay, moment of truth. Let's see what I got. Submit the test. I missed one. Number 6. So close. Was it a word problem? What did I put? Interesting. I didn't think I'd miss that one. Let me work it again. Who knows what I did? Okay. 3a to the negative 1 plus 3a to the negative 1, a to the negative 1 plus 3a to the negative 2. Now, like I said, you have to take those negatives to you have to take those to the denominator. So we're going to have 3 over a plus 1 over 3a. 1 over a here plus 3 over a squared. We multiply by the LCM of all our denominators, which would be inner denominators, which would be 3a squared. I'll take that times 3 over a. Take that times 1 over 3a. Multiply times 1 over a. Multiply that times the 3 over a squared. This a cancels one of these a's, so it leaves me an a there. That 3 cancels that 3. This a cancels one of these a's, so it leaves me an a. That a cancels one of these a's, so it leaves me an a there. This a squared and this a squared cancel. So we're left with 3 times 3 is 9a plus a. I think I put a 9 here, I think. My own sloppy writing. 3a times 1 is 3a, and 3 times 3 is 9. So on top I can factor an a out. What is this exactly? I hate a's. Let's see. 3 times 3 is 9a, and that's an a, so that's 10a. What is that? Is that an a? A, and this is a 9. Okay. So I can factor a 3 out, and that gives me a plus 3. They left that multiplied through, but okay. I think I just shouldn't use a's. I like x's. I don't confuse those with any numbers. But that's the review.